record. Hold on a second. Let me turn my writing tablet on. All right, what do you got?
Sorry, still trying to find something. I guess we can start with this one.
Having a little hard time hearing you, Maddie. Can you either speak closer to the microphone or?
Yeah, let me scoot it closer.
There, that's much better.
So the first one is, so it's -1 plus 5i divided by 2 plus 8i.
Okay. Imaginary numbers. Very easy to add them, very easy to subtract them, very easy to multiply them. Division is a whole different story. This is not really a division problem. What it is make the denominator a real number. How can we do that?
I don't know. We really didn't go over imaginary numbers at all in class.
If you make the denominator the conjugate, you know what I mean by conjugate?
Is it like the -1 and 2?
Yeah, well, it's the opposite sign. Same two terms, the opposite sign.
Yeah.
If I do that, the denominator turns into a real number. Since I can multiply any fraction by the number 1, as long as I multiply the top by the same thing, I'm only multiplying that fraction by the number 1.
Okay.
Okay? Now, what do you get? Let's do the denominator first. And one good way to do this is to think of it as the difference of perfect squares in reverse.
Okay.
Now, you can FOIL these if you need to. Go ahead. Come up with an answer. What do you get?
16i.
Let's do it term by term. When you FOIL it, do the first two terms. What do you get?
64i.
Well, 2 times 2. I'm not looking at the final answer. I don't even know what it is. But I want to make sure you do it step by step. You don't try to do this all in one step in your head. Not the way to do it. The way to do it is to do it step by step. How do you FOIL those two numbers?
So 2 times 2.
Okay, that's 4. What's the next term?
2 times 8.
2 times 8, negative 8i. What's the next term?
Then it's 8 times 8.
No. The I of FOIL is the inside.
Oh, so 8 times
These 2 terms. Well, that's plus 16i. And what's the last term?
8 times 8.
Times I. So it's minus 16i squared. And notice one thing. The two middle terms cancel. They always will if you are multiplying something by its conjugate. The two middle terms always cancel one another out. So what you're left with in the denominator, 4 minus 16i squared. What is 16? What's I squared equal to? If I is equal to the square root of -1, what is I squared equal to?
1.
Negative 1.
No.
Square root of negative 1 times square root of negative 1 is always whatever's in the radical.
Oh, okay.
Okay, so it's negative 1. So this denominator becomes 4 minus 16 times negative 1. What's that equal to? What's 4 minus 16 times negative 1?
Negative 12.
Nope. What's 16 times negative 1?
Negative 16.
What's 4 minus a negative 16?
Oh, positive 12.
Positive 20. Over here on the left. 4 minus a negative 16. That's
Oh,
20. In other words, you change the subtraction sign into an addition sign, and you change the number that was being subtracted, so you end up with 4 plus 16.
okay. Yeah.
Okay? Now, we have to do the numerator. Notice what we did to the denominator. We turned it into a real number, 20. It's no longer in terms of I. And that's the whole point of this exercise, is we don't care if the numerator is an imaginary number. What we care about is make sure we do not have a denominator that is an imaginary number. It's very difficult to divide something into a number of pieces if you're dividing by an imaginary number. There's really no way to even conceive of that. So when you have a problem like this, it's not really a division problem. What it is turning the denominator into a real number. That's the kind of problem it is. Now, we're not quite done. We have to multiply that by that. We still have to multiply the numerator, right?
Mm-hmm.
So what is that? Do this. When I say FOIL, do you know what I mean?
Yeah.
Okay, FOIL those two. What do you get? What's the first? FOIL stands for first, outside, inside, last. What's the first?
Negative 2.
What's the O? Outside. Negative 1 times negative 8i. That's the outside term.
Just 8i.
Plus 8i. That's the inside term.
10i.
Plus 10i. You cannot ignore the sign there. We are writing a polynomial expression. I have to have that plus sign. If I leave that plus sign out, it changes everything.
Hmm.
So you have to use the plus sign when you're writing it as part of an expression. Finally, what's the last?
Negative 1.
What's 5i times minus 8i?
Oh, I thought we were just doing the.
What's that?
I thought you went just to the i's.
No, you got to do the whole last term.
Negative 40i.
Squared. Negative 40i squared. You see why it's I squared?
Because there's 2 i's.
Yeah. In other words, you have to multiply plus 5i times minus 8i. We multiply the numbers, that's minus 40, but you got to multiply the variables also. I times I is I squared. So, if I take this answer, try to simplify it, here's what I get. 2 plus 18i minus 40i squared, all divided by 20. With me?
Wait, where'd you get the 18 from?
8i plus 10i.
Oh, okay. I see.
What's I squared equal to?
-1.
Yeah, this is always what you have to do, is convert any I squared you have to -1. So now, what is the numerator? You have 2 plus 18i minus 40i squared. What's that turn into?
-20i.
Not 20. Well, first of all, let's deal with the 40i squared. What's that?
+40i.
Okay, what's 2 plus 40?
42.
So it's 42 plus 18i, all divided by 20, right?
Yeah.
Can I simplify that?
No.
They're all even numbers. When they're all even numbers, you can always simplify. Means I can divide top and bottom by 2.
Oh, okay.
What does that give you when you divide top and bottom by 2? What's the top divided by 2?
21 plus 9i.
What's the bottom divided by 2?
10.
Can I simplify that any further?
Yeah.
Actually, no. Well, you could, but it doesn't really advance the answer.
Oh, okay.
In other words, I cannot divide top and bottom by a number anymore. I could separate it into 21 over 10 plus 9/10 I, and that actually can be a proper answer. It depends on whether or not they ask you to give the answer in A plus BI format. Does it say that anywhere on this problem?
No.
Well, let me cover it anyway. In other words, the answer we came up with is perfectly fine. Okay?
Yeah.
Let me write it again, just because I got a lot of scribbling on here. So we have 21 plus 9i over 10. Well, if the question said put your answer in A plus BI format, then I got to separate that into two fractions. 21 over 10 plus 9/10 I. That is A plus BI format. What's A?
Oh, 21.
21 over 10. What's B?
9i over 10.
Just 9 over 10. Notice that A and B are real numbers. A is a real number, B is a real number. There's no I in A or B. That's A, that's B. So if the instructions said put this in A plus BI format, what I have here at the top is the only correct answer. If the instructions did not say that, then that is a correct answer also. Same thing, same answer. It's just the one in blue is not in A plus BI format. When you have A plus BI format, you need it to have the A apart and the B apart from the I. All right. You have another one? Hopefully of a similar sort, because that's the best way to learn, is to have me explain how to do one, and then you have another one similar, Make sure you can do it.
So it says simplify,
Okay?
then parentheses, -1 plus 8i, minus another parentheses, -6 minus 7i.
All right. These are easy. This is just addition and subtraction. When you are adding or subtracting, you do the reals, you combine them, and you do the imaginaries, and you combine them. So what do you get when you combine the real number? The -1 and the minus 6.
So would you like distribute the negative sign to the
Well,
frequency,
yeah.
or
Well, yeah, the problem, when you're combining the reals, here's what you have. -1 minus a -6. What's that?
oh um -7?
Nope. Are you doing this on a calculator?
No.
Well, that's good and bad. You need to be able to do this in your head for sure, but you can do it on a calculator, but calculators are all different. Some calculators have one negative sign on them, some calculators have two negative signs. And it makes a difference if you're going to do this. But first of all, let me show you how to do a subtraction. Okay? Hold on. If you are subtracting two numbers, that is the subtraction sign. Is it not?
Mm-hmm.
It's not any of the other negative signs. The negative in front of the 1 is a -1. The negative in front of the 6 is a -6. There is only one subtraction sign in what you're looking at. So when you are subtracting numbers, turn it into an addition and change the sign of what was being subtracted. So it becomes this, -1 plus 6. What's that?
5.
That's what goes there. Now, operate on the imaginary number. You have 8i minus 7i.
1i, -1.
It's plus. It's 1i, but it's plus 1i. It's not minus. In other words, here's what I'm doing. I have 8i minus 7i. That's 1i. And that's your answer.
Oh,
In
okay.
other words, adding, subtracting, even multiplying is a piece of cake. Just add the reals and add the imaginary. Or subtract the reals and subtract the imaginary. Multiplying is just foiling. Turning all of your I squareds into -1. The only problem ever is division. That's because it's not really a division problem. It's making the denominator a real number. That's all division problems are when you're dealing with imaginary numbers. All right, what else?
Multiply parentheses 1 plus 2i, and then another parenthesis 5 plus 6i.
Just foil it. What do you get? Just do it step by step. Don't try to do any more than one step at a time. It's the F of foil.
First,
Which is?
5.
What's the O of foil?
Outside,
What is that?
12.
The outside is this. 1 times positive 6i.
Oh, I was looking wrong. Yeah. Just 6i.
What's the inside?
10i.
Plus 10i. What's the last?
12i squared.
12. It's plus. See, you have to include the sign here. You can't just say 12i. The plus is not assumed. We are writing a polynomial expression. So I need the plus sign. If I write just 12i squared, there's nothing in between the 10i and the 12i squared. I need a plus sign. Okay? Now, let's simplify it. Still got the 5. You can combine those two terms. What do you have? What's 6 apples plus 10 apples?
16i.
Now, what is that? What's I squared? That's the key on these, is always to recognize that I squared is -1.
Yeah.
So what is plus 12i squared?
-12.
Now combine that, because you have two numbers. You got that number and you got that number. It's 5 minus 12.
-17.
-7.
Oh, yeah, that's what I said.
And we still have some I. We have 16i. Here's your answer. -7 plus 16i. So you can see that multiplication is very easy. So all you do is FOIL it and convert your I squareds to -1 and then simplify. The only problem with imaginary numbers is when you have a division problem. It doesn't much matter. I'll make one up. I want to make sure you know how to do it. There's a division problem. It's not really a division problem. Let me give you an example. If I said 1 over square root of 2, is that a division problem?
No.
No, it's rationalizing the denominator, right?
Yeah.
How do you rationalize the denominator?
You multiply it by itself.
By square root of 2 over square root of 2. We can only multiply a fraction by the number 1 without changing its value. What that produces is square root of 2 over 2. That's the answer. Was this a division problem? Not really. It was a rationalize the denominator problem. Same thing with imaginary numbers. They are not division. They are rationalize the denominator. That's what they are. Only you're not rationalizing it, you're realifying. Same thing. You are realifying the denominator. How do you realify the denominator?
You put
What can we multiply every fraction by without changing its value?
3 minus 2i.
3 plus 2i.
Oh, yeah.
Always the conjugate.
Yeah.
And since I can only multiply by the number 1, then the numerator has to be the same thing. That is the number 1. Agreed?
Yeah.
I can multiply any fraction by the number 1 without changing its value.
Mm-hmm.
The beauty of this is you make the denominator real, which is the whole purpose. Let's do the denominator first. Foil it. But you know what? Don't foil it. Notice that whenever you multiply something by its conjugate, the two middle terms always cancel. So the only thing you have is the first term and the last term. You can forget about the O and the I. So what's the first term?
3.
3 times 3.
Yeah.
What's 3 times 3?
9.
That's the first term. That's this term times this term. I know the two middle terms cancel one another out, so the only thing I have left is that term times that term. What is that?
Negative 4 squared.
4i squared.
Oh, yes. Yeah,
Negative 4i squared. Now, simplify that denominator again.
3 minus 2.
Not 3, 9. We're simplifying this denominator over here.
Oh,
Turns into a real number. Eliminates the I. What's I squared equal to?
negative 1.
So what's 9 minus 4 times negative 1? You probably should have a pencil and piece of paper in front of you.
Yeah.
Because I want you to do this. In other words, when I ask you questions like that, if you can't do it in your mind, do it on paper and tell me what you get. What is 9 minus 4i squared? And you know that I squared is negative 1.
Well, would the negative 4 turn into a positive 4?
Well, first of all, start with the I squared. 9 minus 4, what's I squared equal to?
Negative 1.
So this is the problem you're doing. 9 minus 4 times negative 1.
But you multiply it with the negative 4, and then that would become a positive 4 because it's two negatives, right?
Correct.
So then it's just 9 plus 4, which is 13.
Okay. So notice what we've done. We've turned the denominator into a real number. That was the whole purpose. But we still have to operate on the numerator. Those two need to be multiplied together. And this time you do have to FOIL it, every single term. What do you get? First term? That times that.
6.
Second term, outsides.
Also 6.
Outsides are these two.
Oh, yeah. I always
2
get those.
times 2i.
4i.
Insides.
9. 9i.
Plus 9i. Finally, the last. What's 3i times 2i?
6i squared.
Okay, let's just write it like that, 6i squared. Now let's simplify that. We can do a lot of simplification in the numerator. How many total i's do we have?
3 in total.
No, actually we have 4 and 9. We have 13 in total. Right?
Oh, I see. Oh, never mind.
You see why it's just 13i?
Yeah.
And what's the last term equal to? 6i squared. You can always remember that you have to convert, anytime you see an I squared, convert it to -1.
It's, wait, it's 6i.
6i squared is what? If you convert the negative, if you convert the I squared to -1, then what is 6i squared?
Negative 6i.
No, it's just -6.
Oh, because you get rid of that.
Yeah, the I disappears. Whenever you have an I squared, the I disappears. I squared is -1.
Oh, okay.
Okay, all this is still divided by 13, because that was our denominator. Now simplify the numerator. What do you get? 6 plus 13i minus 6.
Well, you could just cancel out the 2 6s.
Okay, what do you have left?
It's 13i over 13.
What's that simplify to?
1.
Not 1. 1 is only when something is divided by the same thing. 13i is not the same as 13.
Is it 1i?
Yes, it's just I. There's your answer. So this whole complicated thing that we started with turns out to be just I.
Oh, okay.
Okay? It's not obvious at all when you look at it that that's what you're going to get is I. You have to go through the process.
Okay.
All right. What else you got, Maddie?
So this one says solve the equation. So it's 3 radical sine x minus 1 equals 15.
Okay? Is that correct?
Yeah.
Okay. What we want is to come up with an answer for x. Which means what we want to do is get rid of anything else that's part of x. What's the first thing we can get rid of?
-1.
That's inside the radical. What's outside the radical?
Can you like divide the 3 into the 15?
You got it. Which gives me square root of x minus 1 equals 5, correct?
Yeah.
Now what? Still trying to get to x. How do I get rid of the radical sign?
Can you multiply?
You square both sides.
Oh, okay.
Whenever you square a radical, you get what was inside the radical. See where I get that step?
Yeah.
So what's x equal to? Solving this equation. X minus 1 equals 25. So next...
So to get rid, do you want to get rid of the 1 and put it on the other side?
Well, how do you do it?
So you'd add 1 to both sides.
So you get this. Right?
Yeah.
Now let's check and make sure that that satisfies the equation. When you substitute 26 for x, you get square root of 25, which is 5. 3 times 5 is 15. That's a good answer.
Okay.
In other words, all we did was just check, make sure that our answer satisfies the equation.
Okay.
What else you have, Matt?
Here's one that's kind of like that one, just so
Okay.
good.
That's good. It's always best to have two of each type. That way I can explain to you how to do it, and then the second one you can do on your own.
So there's radical sign x plus 1 equals another radical sign x plus 6 minus 1.
Like that?
Yeah.
Okay, these are a little harder because you have to get rid of one radical sign first and then do it again. So the solution, whenever you have two radical signs in the same equation, the solution is almost always to isolate one radical sign and square both sides. If I square both sides, what do you get on the left?
So
Whenever you square something that is being square rooted, you get whatever is inside the radical.
yeah, so it's just x plus 1 equals x plus 6 minus 1.
No, the right side's more complicated. The right side, I have the square root of x plus 6 minus 1, and squaring that whole thing. We got to FOIL it. It's square root of x plus 6 minus 1 times itself. Okay? So, here, let me write it real quick right here. This is what I'm doing. You see that?
Yeah.
Well, it's not actually what I'm doing. There's another minus 1 and a minus 1. But the first step of that is to multiply the square root of x plus 6 times the square root of x plus 6. What do you get? What's the square root of a times the square root of a? A. What's the square root of b times the square root of b?
E.
What's the square root of y times the square root of y?
Y.
So what's the square root of x plus 6 times the square root of x plus 6?
X plus 6.
That's the first term. What's the second term? In other words, the outside of FOIL. It's that times that negative 1.
Wait, it's x times negative 1?
Well, it's negative square root of x plus 6. Right? Multiply something by negative 1, it's the same thing, only with the opposite sign in front of it. Now, what's the outside? What's that times that? What's the square root of x plus 6 times negative 1?
Negative x plus 6.
Same thing as the previous term. Now, finally, what's negative 1 times negative 1?
Positive 1.
Okay. Now, it doesn't look like we've made much progress, but let's simplify it. We got x plus 1 on the left. We got, that's the only x plus 6. But we got two of those. So that's minus 2 square root of x plus 6. And then we have a plus 1. Right?
Yeah.
Now, it doesn't look like we've done much, but we've actually done a lot. We've reduced two radical signs to only one radical sign. So the next step is to isolate that and then square both sides. Well, the first thing I need to do is simplify this. Okay? Well, that x cancels with that x. I got a total of 7 on the right side, 6 plus 1. Got a total of 1 on the left side. So if I move all the numbers to the left side, I get this. The only thing I have left on the right side is that. You with me?
Yeah.
Now, again, when you're trying to solve radicals, you isolate the radical and then square both sides. So what's the next step I need to do to isolate the radical?
Square it.
Not yet. I haven't isolated it. You've got to isolate it. By isolating, I mean bring it down to just the square root of something. Well, what's it got? It's got a negative 2 in front of it. How do I get rid of that negative 2?
Multiply the whole thing.
What's the negative 2 doing? The multiplier? Is it adding? Is it subtracting? Is it dividing?
Multiplying.
So how do I get rid of it?
Adding.
What's the opposite of multiplication?
Oh, division.
That's what you do, is divide by negative 2. Both sides. With me?
Yeah.
So what's negative 6 divided by negative 2?
Positive 3.
That's where I'm at. See how I got there?
Yeah.
Now, I've got the radical sign isolated. By that, I mean I don't have anything else outside of the radical sign. So how do I solve it from here?
Now do you square it?
Yeah, you square both sides, and that'll get rid of the radical sign. So it goes on the left.
So 9
Goes on the right.
equals x minus 6.
What's the last step?
So add 6 to both sides to cancel it out.
There's your answer. Now, what was the original equation? We have to check our answer. Sometimes you'll find that that answer doesn't work.
Yeah.
Since I've erased it, tell me the original equation again.
Radical sign x plus 1 equals another radical sign x plus 6 minus 1.
Now let's substitute 15 into there. What's the left become when I substitute 15? In other words, I'm proposing that x equals 15. But before I can be certain of it, I got to substitute it and make sure this thing is still an equation when I substitute x equals 15.
So x plus 1 would be 15 plus 1, which is 16.
What's the square root of 16?
8.
Nope. Square root.
Oh, sorry. 4.
Substitute it on the right.
So 15 plus 6 is 21, minus 1 is 20.
Somehow I've made a mistake. Because the square root of 15 plus 6 is the square root of 21. I think that needed to be 25. And then it would work. I refuse to believe that this equation was not valid. I am more likely to believe that I made a math error. Okay? In other words, I think the answer is x equals 15. But I couldn't prove it here, because if I do that, I get this. Well, that's not true. Square root of 21 minus 1 is not 4.
Yeah.
It would need to be the square root of 25 minus 1. Square root of 25 is 5. Minus 1 is 4. So, at this point, I've worked on this problem for 10 minutes. I don't want to go back and figure out where I made my error. If somebody put a gun to my head and said, tell me what the answer is, I'm going to tell them x equals 15.
Okay.
Okay?
Yeah.
In other words, one of the really, really important steps of math is to check each line you write. Make sure you have not made a mistake. Because what happens is, notice that I had like 9 lines, right?
Yeah.
So if I've made a mistake, I have no idea where it occurred. I don't know if it occurred in line 2 or line 9. Whereas if I'd have been checking at every step of the way, I would know where I made my mistake. Now, it's possible that I did not make a mistake, in which case there would be no solution. Because the one solution I came up with doesn't work.
I have an answer.
15 does not seem to work.
I have an answer key if you want me to check it.
Yeah, I'll bet you anything x equals 15 is correct.
Okay, let me find it really quick. That's weird.
It's not x equals 15?
No, I mean, it's just the answer key he gave us is wrong. It's not even the same problem.
Okay, well, don't have to deal with that. But when you have an equation that has 2 radical signs in it, it is a 2-step process. You have to eliminate one radical sign first, then isolate it again, and eliminate it a second time. It's always a 2-step process, and you'll eventually solve for what's under the radical sign, x. But it's complicated. This is one of the tougher problems you're going to get involving radical signs in equations. This is as hard as it gets when you have 2 radical signs. In other words, if I just have 1 radical sign, let's say this, so all I have to do is square both sides, right?
Yeah.
Now what's the answer? Easy.
Mm-hmm.
But if I have 2 radical signs, I can square both sides, and that'll get rid of the radical sign on the left, but it leaves 1 radical sign on the right.
Yeah.
In other words, here's what I'm going to do. I'm going to square both sides, so you always get whatever's in the radical on the left. But when I square the right side, I got to FOIL it. In other words, when you square that, you get x minus 2 plus 20 times x minus 2 plus 100. With me?
Yeah.
Well, now I simplify. Well, that x, I can subtract x from both sides. I can move the number to the left side. Well, the number is minus 2 plus 100. That's 98. Move it to the right side. That becomes minus 97. The only thing I have left on the right is this. So I've made a lot of progress on the problem. I've narrowed it from 2 radical signs down to 1. Now it's all I got to do is get rid of the 20 and square both sides again.
Yeah.
So getting rid of the 20 is dividing by 20. Squaring both sides becomes 97 squared over 20 squared equals x minus 2. Come up with a number for x. Just remember that that's always the process, and this is as hard a problem as you will get. When they give you an equation with 2 radical signs in it, they don't get much harder than that. But it's not really that hard. You just have to know how to FOIL, how to get rid of radical signs. You get rid of radical signs by squaring it.
Yeah.
All right. We've got about 5 minutes, Maddie. And unfortunately, I don't have any extra time. I have a 6:30 that I have to do. So
Yeah.
what do you got that is a 5-minute problem?
I mean, I guess we could do a factoring one. That's pretty quick.
That is a good one, actually. Let's do it.
So it's 4x squared minus 9x equals 9.
Like that?
Yeah.
Okay. What kind of this is a quadratic. How do you solve quadratics? What's the typical way? It's not the way you do it 100% of the time, but you do it with this kind of a problem.
Split it into 2.
Nope. You put everything on one side and leave 0 on the other.
Oh, yeah, yeah.
That's the typical way to solve quadratics. So I'm moving the 9 to the left, leaving 0 on the other.
Okay, yeah.
Now, the beauty of this is that if I can factor the left side, I'm going to have 2 things multiplied together equal to 0, and I'm going to be able to set each one equal to 0. So can you factor the left? Do a quadratic factoring.
So
what I call it. Separate the x's.
Yeah, so 2x in each log.
It doesn't have to be that, incidentally. It could be 4x and 1x. But
yeah.
Usually this is a trial and error process. Usually what you want to do is use the factors that are closest together. 2 and 2 are closer together than 4 and 1. So I'm going to start off by trying 2 and 2. What are the signs? Are they the same or are they opposite?
They're different.
Okay, so that's a plus there and a minus there. What are factors of 9? Obviously 9 and 1. What are other factors?
3 and 3.
Normally I would suggest trying the closest factors. Trying a 3 there and a 3 there. Notice that produces no middle term. Produces the first term and the last term, but it does not produce a middle term.
Yeah.
So that's not right. I could try 9 and 1. Does that help?
I think so.
Actually, it doesn't. I try 9 there and 1 there. I get an 18x in the middle. I get a minus 2x. That's 16x, not the same number. That's not right. Well, I've exhausted all factors of 9. What's another thing to try? How about 4x and x?
Oh, okay.
That
Yeah.
still multiplies to 4x squared, so we're still safe. Plus,
And then
minus. Well, what happens if we try 3 and 3 this time? What do we get in the middle?
3x.
No, this term is always produced from the O and the I of the coil.
Oh,
So the inside is plus 3x. What's the outside? It's 4x times negative 3.
Negative 12.
X. Add them together, combine them, what do you get?
Negative 9x.
Which is our middle term.
Yeah.
It means we've done it correctly. So here's our solution. 4x plus 3 times x minus 3 equals 0. Notice the trial and error nature of this. Whenever you're trying to factor one of these kind of quadratics, just kind of have to try a lot of different combinations till you produce the middle term. Middle term is always the key term. Okay?
Yeah.
Now, what's the solution? I got over here on the bottom right, I got 4x plus 3 times x minus 3 equals 0. So what two solutions does that give you? In algebra, the most important rule you can remember from algebra is if you multiply two numbers together and you get 0, what does one of the numbers have to be?
0.
Yes, the only way two numbers multiply together to give 0. You can't have two non-zero numbers multiplying to give 0. There are no two non-zero numbers. So the next step is to set each of these terms equal to 0 and solve. So what's one of the solutions? X equal to what? Set that one equal to 0. What do you get?
Negative 3.
No, you get positive 3. If x minus 3 equals 0, then x equals 3.
Oh, okay.
So x equal 3 is one solution. What's the other solution?
I mean, x equals 0.
No, this one equals 0.
Yeah.
So set that equal to 0 and solve for x.
So 4 times 0 plus 3. What? I'm so confused.
Hold on. This eraser doesn't work really well. Here's what I'm doing. Setting 4, hold on. Top left. Setting 4x plus 3 equal to 0. How do you solve that? First of all, do you see why I'm setting 4x plus 3 equal to 0?
Yeah.
Okay, now solve that equation. That's as simple as it gets.
Do you subtract 3 from both sides?
Okay, so now I got 4x equal minus 3. Now what?
Divide.
Because 4 is a multiplier.
Yeah.
So you're going to divide both sides by 4. Gets rid of the 4 on the left, so now I got x equals minus 3/4. That's the other solution.
Okay.
Now, sometimes this principal rule of algebra says that if you have a times b equals 0, well then either a or b equals 0. It doesn't say both have to equal 0. It
Yeah.
says one of them has to. So we've come up with two solutions here, and it's possible that one of them might not work. Might be an extraneous solution. So the only thing we can do is to substitute it back into the original equation and see if it's true or not. What's the original equation again?
4x squared minus 9x equals 9.
4x squared minus 9x equals 9. Let's try the easy one. X equals 3. Does that work?
Yes.
Okay. How about x equal minus 3/4? Let's see if that works. And you kind of have to do it this way. There's so many negative signs in here. If you want to make sure you do not drop a negative sign, you have to do it like this.
Yeah.
What is minus 3/4 squared?
6 over
Nope.
16.
What's minus 3 squared?
Oh, 9
Over
over
16. So
yeah.
it's 4 times 9 over 16. And this turns into a positive 27/4. You see why that turns into a positive?
Yeah.
Okay. Now the question is that a true statement? Well, I'm out of room again, unfortunately. Hold on, let me make some room. And you kind of have to do this with all of these, because you're getting to a point in algebra where they're going to start giving you equations where one of the solutions does not work. And it's called an extraneous solution. Okay? So, 4 times 9/16. That's the same as 9/4. With me?
Yeah.
Plus 27/4. Is that equal to 9?
I don't think so.
It is.
Oh.
How do you add 9/4 and 27/4? That's 36/4,
Oh, okay.
which is 9.
Yeah.
So what I've just proven is that both of these are acceptable. Both 3 and 9/16, or excuse me, minus 3/4 are good solutions. They both are solutions to that original equation. Now, just so you know, when you have a quadratic, you usually have two solutions. So you're kind of expecting two solutions from the beginning.
Yeah.
All right, Maddie, listen, I have not paid attention to the clock, and I've run over by 5 minutes. I do need to leave and go to my next appointment. Well, hopefully this has been helpful.
Yeah.
All right. You have a good evening. Get good sleep tonight. Good luck on your test tomorrow.
Thank you.
You're welcome.